Part II, Chapter 12, Part 3 of A Popular History of Astronomy during the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. A Popular History of Astronomy during the 19th Century by Agnes Mary Clerke. Chapter 12, Stars and Nebulae, Part 3. Every kind and degree of variability is exemplified in the heavens. At the bottom of the scales are stars like the sun, of which the lustre is, tried by our instrumental means, sensibly steady. At the other extreme are ranged the astounding apparitions of new or temporary stars. Within the last 36 years, 11 of these stellar guests, as the Chinese call them, have presented themselves, and we meet with a 12th no farther back than April 27, 1848. But of the new star in Ophiuchus, found by Mr. Hind on that night, little more could be learnt than of the brilliant objects of the same kind observed by Tycho and Kepler. The spectroscope had not then been invented. Let us hear what it had to tell of later arrivals. About 30 minutes before midnight of May 12, 1866, Mr. John Birmingham of Millbrook, near Tuam, in Ireland, saw with astonishment a bright star of the second magnitude, unfamiliarly situated in the constellation of the Northern Crown. 4 hours earlier, Schmidt of Athens had been surveying the same part of the heavens, and was able to testify that it was not visible there. That is to say, a few hours, or possibly a few minutes, sufficed to bring about a conflagration, the news of which may have occupied hundreds of years in travelling to us across space. The rays which were its messengers, admitted within the slit of Sir William Huggins's spectroscope, May 16, proved to be of a composition highly significant as to the nature of the catastrophe. The star, which had already declined below the third magnitude, showed what was described as a double spectrum. To the dusky flutings of Secchi's third type, 4 brilliant rays were added. The chief of these agreed in position with lines of a hydrogen, so that the immediate cause of the outburst was inferred to have been the eruption or ignition of vast masses of that subtle kind of matter, the universal importance of which throughout the cosmos is one of the most curious facts revealed by the spectroscope. T Coronæ, as the new star was called, quickly lost its adventitious splendour. 9 days after its discovery, it was again invisible to the naked eye. It is now a pale yellow, slightly variable star near the 10th magnitude, and finds a place as such in Argelander's charts. It was thus obscurely known before it made its sudden leap into notoriety. The next temporary, discovered by Dr. Schmidt at Athens, November 24, 1876, could lay no claim to previous recognition, even in that modest rank. It was strictly a parvenu. There was no record of its existence until it made its appearance as a star of nearly the third magnitude in the constellation of the Swan. Its spectrum was examined December 2 by Cornu at Paris, and a few days later by Vogel and O. Lassi at Potsdam. It proved of a closely similar character to that of T Coronæ. A range of bright lines, including those of hydrogen and probably of helium, stood out from a continuous background impressed with strong absorption. It may be presumed that in reality the gaseous substances which, by their sudden incandescence, had produced the apparent conflagration, lay comparatively near the surface of the star, while the screen of cooler materials intercepting large portions of its light was situated at a considerable elevation in its atmosphere. The object meanwhile steadily faded. By the end of the year it was of no more than 7th magnitude. After the second week of March, 1877, strengthening twilight combined with the decline of its radiance to arrest further observation. It was resumed September 2 at Dunecht, with a strange result. Practically the whole of its scanty light, it had then sunk below the 10th magnitude, was perceived to be gathered into a single bright line in the green, and that the most characteristic line of gaseous nebulae. The star had, in fact, so far as outward appearance was concerned, become transformed into a planetary nebula, many of which are so minute as to be distinguishable from small stars only by the quality of their radiations. It is now, having sunk to about the 14th magnitude, entirely beyond the reach of spectroscopic scrutiny. Perhaps none of the marvellous changes witnessed in the heavens has given a more significant hint as to their construction than the stellar blaze kindled in the heart of the great Andromeda nebula, some undetermined number of years or centuries before its rays reached the earth in the month of August 1885. The first published discovery was by Dr. Hartwig at Dorpat on August 31, but it was found to have been already seen on the 19th by Mr. Isaac W. Ward of Belfast, and on the 17th by M. Ludovic Gouly of Rouen. The negative observations on the 16th of Temple and Max Wolf limited very narrowly the epoch of the apparition. Nevertheless, it did not, like most temporaries, attain its maximum brightness all at once. When first detected, it was of the 9th. By September 1, it had risen to the 7th magnitude, from which it so rapidly fell off that in March it touched the limit of visibility, 16th magnitude, with the Washington 26-inch. Its light bleached very perceptibly as it faded. During the earlier stages of its decline, the contrast was striking between the sharply defined, ruddy disk of the star and the hazy greenish-white background upon which it was projected, and with which it was inevitably suggested to be in some sort of physical connection. Let us consider what evidence was really available on this point. To begin with, the position of the star was not exactly central. It lay 16 seconds of arc to the southwest of the true nebular nucleus. Its appearance did not then signify a sudden advance of the nebula towards condensation, nor was it attended by any visible change in it save the transient effect of partial effacement through superior brightness. Equally indecisive information was derived from the spectroscope. To Vogel, Hasselberg, and Young, the light of the nova seemed perfectly continuous, but Huggins caught traces of bright lines on September 2, confirmed on the 9th, and Copeland succeeded on September 30 in measuring 3 bright bands with an acute angled prism specially constructed for the purpose. A shimmer of F was suspected, and had also been perceived by Mr. O.T. Sherman of Yale College. Still, the effect was widely different from that of the characteristic blazing spectrum of a temporary star, and prompted the surmise that here, too, a variable might be under scrutiny. The star, however, was certainly so far new that its rays, until their sudden accession of strength, were too feeble to affect even our reinforced senses. Not one of the 1,283 small stars recorded in charts of the nebula could be identified with it, and a photograph taken by Dr. Common, August 16, 1884, on which a multitude of stars down to the 15th magnitude had imprinted themselves, showed the uniform soft gradation of nebulous light to be absolutely unbroken by a stellar indication in the spot reserved for the future occupation of the nova. So far, then, the view that its relation to the nebula was a merely optical one might be justified, but it became altogether untenable when it was found that what was taken to be a chance coincidence had repeated itself within living memory. On the 21st of May, 1860, M. Auwers perceived at Königsberg a 7th magnitude star shining close to the centre of a nebula in Scorpio, numbered 80 in Messier's catalogue. 3 days earlier it certainly was not there, and 3 weeks later it had vanished. The effect to Mr. Pogson, who independently discovered the change May 28, was as if the nebula had been replaced by a star, so entirely were its dim rays overpowered by the concentrated blaze in their midst. Now, it is simply incredible that two outbursts of so uncommon a character should have accidentally occurred just on the line of sight between us and the central portions of two nebulae. We must then conclude that they showed on these objects because they took place in them. The most favoured explanation is that they were what might be called effects of overcrowding, that some of the numerous small bodies, presumably composing the nebulae, jostled together in their intricate circlings, and obtained compensation and heat for their sacrifice in motion. But this is scarcely more than a plausible makeshift of perplexed thought. Mr. W. H. S. Monk, on the other hand, has suggested that new stars appear when dark bodies are rendered luminous by rushing through the gaseous fields of space, just as meteors kindle in our atmosphere. The idea, which has been revived and elaborated by Dr. Seeliger of Munich, is ingenious, but was not designed to apply to our present case. Neither of the objects distinguished by the striking variations just described is of gaseous constitution. That in Scorpio appears under high magnifying powers as a compressed cluster. That in Andromeda is perhaps, as Sir J. Herschel suggested, optically nebulous through the smallness of its constituent stars, if stars they deserve to be called. On the 8th of December, 1891, Dr. Max Wolf took a photograph of the region about Chi Aurigæ. No stranger so bright as the 8th magnitude was among the stars depicted upon it. On the 10th, nevertheless, a stellar object of the 5th magnitude, situated a couple of degrees to the northeast of Beta Tauri, and previously unrecorded, where 11th magnitude stars appeared, imprinted itself upon a Harvard negative. Subsequent photographs taken at the same place showed it to have gained about half a magnitude by the 20th, but the plates were not then examined, and the discovery was left to be modestly appropriated by an amateur, the Rev. Dr. Anderson of Edinburgh, by whom it was announced, February 1, 1892, through the medium of an anonymous postcard to Dr. Copeland, the Astronomer Royal for Scotland. By him and others, the engines of modern research were promptly set to work, and to good purpose. Nova Aurigæ was the first star of its kind studied by the universal chemical method. It is the first, accordingly, of which authentic records can be handed down to posterity. They are of a most remarkable character. The spectrum of the new object was photographed at Stonyhurst and South Kensington on February 3. A few days later at Harvard and Lick in America, at Potsdam and Héronie on the continent of Europe. But by far the most complete impression was secured February 22, with an exposure of 1 hour and 3/4 by Sir William and Lady Huggins, through whose kindness it is reproduced in Plate 5, Figure 1. The range of bright lines displayed in it is of astonishing vividness and extent. It includes all the hydrogen rays dark in the spectrum of Sirius, separately printed for comparison, besides many others still more refrangible, as yet unidentified. Very significant, too, is the marked character of the great prominence lines H and K. The visual spectrum of the nova was splendidly effective. A quartet of brilliant green rays, two of them due to helium, caught the eye, and they had companions too numerous to be easily counted. The hydrogen lines were broad and bright. C blazed, as Mr. Espin said, like a danger signal on a dark night. The sodium pair were identified at Tulse Hill, and the yellow helium ray was suspected to lurk close behind them. Figure 2 in the same plate shows the spectrum as it was seen and mapped by Lady Huggins, February 226, together with the spectra employed to test the nature of the emissions dispersed in it. One striking feature will be at once remarked. It is that of the pairing of bright with dark lines. Both in the visible and the photographic regions, this singular peculiarity was unmistakable, and since the two series plainly owned the same chemical origin, their separate visibility implied large displacement. Otherwise they would have been superposed, not juxtaposed. Measurements of the bright rays accordingly showed them to be considerably pushed down towards the red, while their dark companions were still more pushed up towards the blue end. Thus the spectrum of Nova Aurigæ, like that of Beta Lyrae, with which it had many points in common, appeared to be really double. It was supposed to combine the light of two distinct bodies, one of a gaseous nature moving rapidly away from the earth, the other giving a more sun-like spectrum, approaching it with even higher speed. The relative velocity determined at Potsdam for these oppositely flying masses amounted to 550 miles a second, and this prodigious rate of separation was fully maintained during 6 weeks. It did not then represent a mere periastral rush past. To the bodies exhibiting its effects and parting company for ever under its stress, it must have belonged with slight diminution in perpetuity. The luminous outburst by which they became visible was explained by Sir William Huggins in a lecture delivered at the Royal Institution, May 13, 1892, on the tidal theory of Klinkerfues and Wilsing. Disturbances and deformations due to the mutual attraction of two bulky globes at a close approach would, he considered, give rise to enormous eruptions of the hotter matters from within, immensely greater but similar in kind to solar eruptions, and accompanied probably by large electrical disturbances. The multiple aspect and somewhat variable character of both bright and dark lines were plausibly referred to processes of reversal, such as are nearly always in progress among sun spots. But the long duration of the star's suddenly acquired lustre did not easily fit in with the adopted rationale. A direct collision, on the other hand, was out of the question, since there had obviously been little, if any, sacrifice of motion, and the substitution of a nebula for one of the stars compelled recourse to scarcely conceivable modes of action for an explanation of the perplexing peculiarities of the compound spectrum. An unexpected dénouement, however, threw all speculations off the track. The nova contained most of its brightness, fluctuations notwithstanding, until March 9, after which date it ran swiftly and uniformly down towards what was apprehended to be total extinction. No marked change of spectrum attended its decline. When last examined at Tulse Hill, March 24, all the more essential features of its prismatic light were still faintly recognizable. The object was steadily sinking on April 26, when a supposed final glimpse of it was caught with the Lick 36 inch. It was then of about the 16th magnitude, but on August 17 it had sprung up to the 10th, as Professors Holden, Schaeberle, and Campbell perceived with amazement on turning the same instrument upon its place. And to Professor Barnard it appeared 2 nights later, not only revived, but transformed into the nucleus of a planetary nebula 3 minutes across. The reality of this seeming distension, however at once disputed, was eventually disproved. It unquestionably arose from the imperfect focusing power of the telescope for rays of unusual quality. The rekindled nova was detected in this country by Mr. H. Corder, on whose notification Mr. Espin, on August 21, examined its nearly monochromatic spectrum. The metamorphosis of Nova Cygni seemed repeated. The light of the new object, like that of its predecessor, was mainly concentrated in a vivid green band, identified with the chief nebular line by Copeland, von Goddard, and Campbell. The second nebular line was also represented. Indeed, the last named observer recognized nearly all the 18 lines measured by him in the nova as characteristic of planetary nebulae. Of particular interest is the emergence in the star spectrum photographed by von Goddard of an ultraviolet line originally discovered at Tulse Hill in the Orion Nebula, which is also very strong in the Lyra Annular Nebula. Obviously, then, the physical constitution of Nova Aurigæ became profoundly modified during the 4 months of its invisibility. The spectrum of February was, or appeared, compound. That of August was simple. It could be reasonably associated only with a single light source. Many of the former brilliant lines, too, had vanished and been replaced by others, at first inconspicuous or absent. As a result, the solar prominence type, to which the earlier spectrum had seemed to conform, was completely effaced in the later. The cause of these alterations remains mysterious, yet its effects continue. The chromatic behaviour of the semi-extinct nova, when scrutinized with great refractors, shows its waning light to be distinctly nebular. Like nearly all its congeners, the star is situated in the full stream of the Milky Way, and we learn without surprise that micrometrical measures by Burnham and Barnard failed to elicit from it any sign of parallactic shifting. It is hence certain that the development of light, of which the news reached the earth in December 1891, must have been on a vast scale and of ancient date. Nova Aurigæ, at its maximum, assuredly exceeded the sun many times in brightness, and its conflagration can scarcely have occurred less, and may have occurred much more, than 100 years ago. By means of the photographic surveys of the skies, carried on in both hemispheres under Professor Pickering's superintendence, such amazing events have been proved to be of not infrequent occurrence. Within 6 years 5 new stars were detected from Draper Memorial, or chart plates by Mrs. Fleming, besides the retrospective discovery of a 6th, which had rapidly burnt itself out 8 years previously in Perseus. Nova Normae was the intermediate successor of Nova Aurigæ. Nova Carinae and Nova Centauri lit up in 1895, the latter in a pre-existent nebula. Nova Sagittarii and Nova Aquilae attained brief maxima in 1898 and 1899 respectively. Now, 3 out of these 5 stars reproduced with singular fidelity the spectrum of Nova Aurigæ. They displayed the same brilliant rays, shadowed invariably on their blue sides by dark ones. Palpably, then, the arrangement was systematic and significant. It could not result merely from the casually directed opposite velocities of bodies meeting in space. The hypothesis of stellar encounters accordingly fell to the ground, and has been provided with no entire satisfactory substitute. Most speculators now fully recognize that motion displacements cannot be made to account for the doubled spectra of novae, and seek recourse instead to some kind of physical agency for producing the observed effect. And since this is also visible in certain permanent though peculiar objects, notably in P Cygni, B Lyrae, and Eta Carinae, the acting cause must also evidently be permanent and inherent. The new star of the new century was a visual discovery. Dr. Anderson duplicated with added éclat his performance of 9 years back. In the early morning of February 22, 1901, he perceived that Algol had a neighbour of nearly its own brightness, which a photograph taken by Mr. Stanley Williams at Brighton proved to have risen from below the 12th magnitude within the preceding 28 hours. And it was still swiftly ascending. On the 23rd it outshone Capella. For a brief space it took rank as the premier star of the northern hemisphere. A decline set in promptly, but was pursued hesitatingly. The light fluctuated continually over a range of a couple of magnitudes, and with a close approach during some weeks to a 3-day periodicity. A year after the original outburst, the star was still conspicuous with an opera glass. The spectrum underwent amazing changes. At first continuous, save for fine dark lines of hydrogen and helium, it unfolded within 48 hours a composite range of brilliant and dusky bands disposed in the usual fashion of novae. These lasted until far on in March, when hydrogen certainly, and probably other substances as well, ceased to exert any appreciable absorptive action. Blue emissions of the Wolf-Rayet type then became occasionally prominent, in remarkable correspondence with the varying lustre of the star. Finally, a band at lambda 3969, found by Wright at Lick to characterize nebular spectra, assumed abnormal importance, and in July the nebular transformation might be said to be complete. Striking alterations of colour attended these spectral vicissitudes. White to begin with, the star soon turned deep red, and its redness was visibly intensified at each of its recurring minima of light. Blanching, however, ensued upon the development of its nebulous proclivities, and its surviving rays are of a steely hue. All the more important investigations of Nova Persei were conducted by photographic means. Libraries of spectral plates were collected at the Yerkes and Lick observatories, at South Kensington, Stonyhurst, and Potsdam, and await the more exhaustive interpretation of the future. Meanwhile, extraordinary revelations have been supplied by immediate photographic delineation. On August 22 and 23, 1901, Professor Max Wolf, by long exposures with the 16-inch Bruce twin objectives of the Koningsstuhl Observatory, Heidelberg, obtained indications of a large nebula finely ramified, extending southeast of the nova, and the entire formation came out in 4 hours, with the Yerkes 2-foot reflector directed to it by Mr. Ritchie on September 20. It proved to be a great spiral encircling, and apparently emanating from the star; but if so, tumultuously, and under stress of catastrophic impulsions. A picture obtained by Mr. Perrine with the Crossley refractor in 7 hours 19 minutes on November 7 and 8 disclosed the progress of a startling change. Comparison with the Yerkes photograph showed that during the intervening 48 days 4 clearly identifiable condensations had become displaced, all to the same extent of about 90 seconds of arc, and in fairly concordant directions, suggesting motion round the nova as well as away from it. The velocity implied, however, is so prodigious as virtually to exclude the supposition of a bodily transport of matter. It should be at the rate of no less than 20,000 miles a second, admitting the object to be at a distance from us corresponding to an annual parallax of 1/10 of a second, and actual measurements show it to be indefinitely more remote. The fact of rapid variations in the nebula was reaffirmed, though with less precision, from Yerkes photographs of November 9 and 13, Mr. Ritchie inferring a general expansion of its southern portions. Much further evidence must be at hand before a sane judgment can be formed as to the nature of the strange events taking place in that secluded corner of the galaxy, and it is highly probable that the illumination of the nebulous wreaths round the star will prove no less evanescent than the blazing of the star itself. We have been compelled somewhat to anticipate our narrative as regards inquiries into the nature of nebulae. The excursions of opinion on the point were abruptly restricted and defined by the application to them of the spectroscope. On August 29, 1864, Sir William Huggins sifted through his prisms the rays of a bright planetary nebula in Draco. To his infinite surprise, they proved to be mainly of one colour. In other words, they avowed their origin from a mass of glowing vapour. As to what kind of vapour it might be, by which Herschel's conjecture of a shining fluid diffused at large throughout the cosmos was thus unexpectedly verified, an answer only partially satisfactory could be afforded. The conspicuous bright line of the Draco nebula seemed to agree in position with one emitted by nitrogen, but has since proved to be distinct from it. Of its two fainter companions, one was unmistakably the F line of hydrogen, while the other, in position intermediate between the two, still remains unidentified. By 1868, Huggins had satisfactorily examined the spectra of about 70 nebulae, of which one-third displayed a gaseous character. All of these gave the green ray fundamental to the nebular spectrum, and emanating from an unknown form of matter named by Sir William Huggins nebulum. It is associated with 7 or 8 hydrogen lines, with 3 of yellow helium, and with a good many of undetermined origin. The absence of the crimson radiation of hydrogen, perceived with difficulty only in some highly condensed objects, is an anomaly very imperfectly explained as a physiological effect connected with the extreme faintness of nebular light. An approximate coincidence between the chief nebular line and a fluting of magnesium having been alleged by Lockyer in support of his meteoritic hypothesis of nebular constitution, it became of interest to ascertain its reality. The task was accomplished by Sir William and Lady Huggins in 1889 and 1890, and by Professor Keeler, with the advantages of the Mount Hamilton apparatus and atmosphere, in 1890–91. The upshot was to show a slight but sure discrepancy as to place, and a marked diversity as to character, between the two qualities of light. The nebular ray, wave-length 5,007 millionths of a millimetre, is slightly more refrangible than the magnesium fluting edge, and it is sharp and fine, with no trace of the unilateral haze necessarily clinging even to the last remnant of a banded formation. Chapter 12, Part 3.